So our essential question, why is it important to know how to evaluate expressions, use order of operations, distributive property, and combined like terms? Hopefully you'll be able to answer that when we're done with this lesson. First, we are going to start with order of operations. Now I've changed it up a little bit than what some of you might be familiar with. Okay, where typically you're familiar with the P coming first, PEMDAS. But I'm going to have you write it a certain way, and instead of the P, I've changed it to a G, so it's GEMDAS. The G representing all grouping symbols, because the parentheses are just like that. But there are other grouping symbols that would also go first if you didn't see the parentheses in there, or if you had lots of different ones, then the grouping symbols also go in certain orders. So you've got your parentheses, you have the square brackets, and you have the curly brackets, and then a fraction bar can also be used as a grouping symbol, where you have some stuff on top and some stuff on bottom. And then you would have to do stuff on top and stuff on bottom, so that fraction bar works kind of like a grouping symbol as well. Then you have the E. E is still exponents, so that's when you have like 3 to the second power. So that would be your exponent, so you would have to do that part after you do all the grouping symbols before you do any of the rest. Next, multiply and divide, and notice I have these together like this, okay? You never write this and string it out all in one line. That's what I'm talking about is like, okay, we don't want to write it that way. You're going to write G, E, the MD, because they have equal importance and they are done at the same time, and you do whichever of the two comes first. So if you have a divide in the problem first, you're going to do the divide first, and we're going to see an example a little bit later. And then add and subtract also go on the same line. And again, they have equal importance. You do whichever of those two comes first. So multiply and divide from left to right. Okay, that's an important part. You do whichever of those two comes first. Then you have your add and subtract. And again, from left to right, you do whichever of those two comes first. So let's take a look at an example. And we're going to use the order of operations there to simplify this expression. So first we have our grouping symbols. So we look through the problem to see if we have any grouping symbols. Okay, we do have some right here. There's some parentheses. And then again, you have the fraction bar. So we have to do all the stuff that's on top and all the stuff that's on bottom before we can do the fraction bar, which also represents divide. So on top, we have to do the parentheses part first. So 3 times 17 minus 4 is 13, minus 6 plus 3. And then on the bottom, 24 divided by 6 times 3, minus 2. So as long as the bottom and the top don't affect each other, I'm usually okay if you do one step on top and one step on bottom at the same time. Here, I did not. So I didn't do both of them at the same time because I want to make sure that I do my order of operations in order. So after the grouping symbols, next comes exponents. So then I would look through the top to see if there's any exponents. There aren't any. I would look through the bottom to see if there are any exponents, and there aren't any. So then we go next to multiply and divide. Now, if we look just at the top first, so if I look at just the top part, we're doing multiply and divide. There is only one part that is multiply, the 3 times 13. So we're going to go ahead and do that 3 times 13. So 39 minus 6 plus 3. Everything else gets copied down exactly the way it is. You just did the 3 times 13. Now on the bottom, if we look at the bottom, there's a divide and a multiply. But if you notice, the divide comes first. So you have to do that divide part first. So we're going to do 24 divided by 6, which is 4, and then times 3 minus 2. So that's an example of where I did one thing on top and one thing on bottom at the same time. Now we still have a multiply, so I'm going to finish up the multiply on the bottom. So we have 39 minus 6 plus 3 on top. And on the bottom, I still have this multiply, so 4 times 3 is 12 minus 2. Now we've finished the multiply and divide. We're going to move on to the add and subtract. So on top, you have both. You have a subtraction and an addition. You do whichever comes first. So the subtraction comes first. You're going to do the subtraction first. So we've got 33 plus 3. And then you can do the bottom. 12 minus 2 is 10. And then 33 plus 3, 36 over 10. And then there's multiple ways to write your final answer. You will have to simplify this. 36 over 10 is not finished. So remember, you can divide the top by 2. You could divide the bottom by 2. And on the bottom, you'd get a 5. On the top, you'd get 18. So this is one way. That's an improper fraction. You can write it as a mixed number. So 5 goes into 18 3 times. Okay, remember 5 times 3 is 15. So that means there's 3 left over. Because 15 plus 3 is where the 18 comes from. Denominator stays the same. It's still a 5. This would also be an acceptable answer. And in this case, you could write it as a decimal because it is exactly 3.6. But you cannot always write your answers in decimal form. If it is a repeating decimal, okay, for example, if on your calculator you see a 4.333333333, and basically that keeps on going, you cannot write your answer as a decimal. You would have to leave it in fraction form. Decimals are not allowed when they repeat. No, you cannot write a 4.3 with the line on top. You cannot plug a 4.3 into a problem and check it and get the answer that you need back. You could only do that with a fraction. So you would have to give me an exact answer. You cannot round it, not at this time. Next, evaluate expressions. So we're going to look for variables in an expression and replace the appropriate indicated real number value. So that's how we evaluate expressions. So you take the variable out, you put the number in. After you've taken the variable out and you put the number in, then it's just order of operations, like on the last slide. So here's the example. So here it says that our expression, evaluate that expression, this expression, when x is equal to 5. So everywhere we see an x, we're going to replace it with a 5. So we have 2 times 5 squared plus 3 times 5 minus 2. So I just color-coded it a little bit there. Okay, so see the variable change to a 5. Now you use order of operations. So first are grouping symbols, but if you look inside the parentheses, there's nothing in there to do. It's just a plain number. So then we look at exponents. We do have an exponent in this case right there, 5 squared. Okay, so we have to do the exponent before you multiply. Remember the order, GEMDAS. Exponents first, then multiplication. So it's 2 times 25 plus 3 times 5 minus 2. Notice I just copy everything else down. I did the 5 squared. That's your exponents. And after exponents is multiply and divide. We have 2 multiplying parts. They don't affect each other because there's that plus in the middle, so they're totally separate. So I'm going to go 2 times 25, which is 50, plus 3 times 5, which is 15, minus 2. And now we do our add and subtract. The add comes first, so you do the add first. 65 minus 2, 63. So your answer is 63. Next, distributive property. So the process to find the product of a number and a sum or difference. Okay, so here's a couple of abstract examples. So we're looking for the product of a number and the sum. Here we're looking for the product of a number and a difference. So it's where you're multiplying a number with something that's being added together. And some of you may be familiar with this from previous classes. So you just take whatever you're multiplying on the outside, that number, and you're going to multiply it with everything on the inside. So A times B and A times C. So you go A times B plus A times C. And you could write it just AB plus AC. Same thing with the subtracting problem. A times B and then A times C. So A times B minus A times C. And you could write it just AB minus AC. So let's look at an example where we're going to simplify. We're just using distributive property here. You do have to be careful if that number on the outside has a positive or negative on it. Okay, like this one has a negative. Then you have to be careful with the inside if there's positives and negatives. So this one's pretty straightforward. You just have to be careful with that negative. So it's negative 3 times x plus negative 3 times 2. So negative 3x plus negative 6. You could also write that negative 3x minus 6. Now typically you could go straight from this expression to that answer, but I'm just showing you those middle steps and being careful with that negative along the way. And then add or subtract parts that have the same variable and exponent parts. So there's two examples here that we're going to look at, and we're combining like terms. Let's just look at one at a time. Okay, so combining like terms, we want to add or subtract parts that have the same variable and exponent parts. So if you look at this expression, number 1, we have x squareds in the problem. We also have x's in the problem. Difference is the x is not the same as an x squared. Those are different kind of variables. So when we combine, we're going to combine all the x squared parts, and make sure you always keep that sign in front of the number. It's always the sign in front. So you have 3x squared minus 5x squared. Then we're going to do the x's. So it's a minus 6x and a plus 9x. So minus 6x plus 9x. And then we do the plus 2 and the plus 4. So it's a positive 2 and a positive 4. And now we can combine. So 3 minus 5, you just combine the numbers in front of those variable parts. The variable part does not change. 3 minus 5 is negative 2. A negative 6 plus 9 is a positive 3, and the variable part is an x. And then you have 2 plus 4, which is 6. So this is our final answer, negative 2x squared plus 3x plus 6. And the next example. So number 2, 5 minus 2 times x minus 6. So if you look at part of it looks like what we did on the previous slide. Make sure that that minus in front of the 2 stays with the 2. Okay, so it's a negative 2 times x and a negative 2 times the minus 6. Okay, so you have to be careful with those double negatives there. So you have negative 2x, and what happens when you multiply a negative times a negative? It becomes a plus 12. So 2 times 6 is 12. You add a minus in front of the 2 and a minus in front of the 6. When you multiply two negatives, that becomes a positive. And then you have to remember that you had a 5 in front. Okay, so that just comes straight down. Now you combine like terms. So 5 plus 12, those are both constants. So you would combine those. So we have negative 2x plus 17. And that's your final answer. Okay, make sure if you have any questions, you write those down, come and talk to me.